Hello, everyone, and thank you for joining us. In our session, we are going to introduce you to the Rubin Observatory and how they are running their astronomical pipelines with HTCondor on Google Cloud Platform. With us today, we have some of the members of the team that worked on this project. Hsin-Fang, Data Management Science Analyst and Engineer, Aura and Rubin Observatory. Ross Thomson, Cloud Solutions Architect, Scientific Computing, Google Cloud. Myself, Jess Masciarelli, Field Sales Representative, Google Cloud, and Flora Huang, Customer Engineer, Google Cloud. During our session, you're going to learn a little bit about the Rubin Observatory. We're going to talk through the technical partnership. We'll highlight some of the project aspects, talk about the technical architecture. You're going to see an exciting demo, and we're going to end with some questions and answers. And with that, I would like to introduce you to Hsin-Fang with the Rubin Observatory.
Thank you, Jess. In Rubin Observatory, we are building a system to provide a vast astronomical data set for new discoveries in our universe. Rubin Observatory is the first U.S. national observatory that's named after a woman. Vera Rubin, as you see here, was a female astronomer who obtained critical data for the understanding of dark matter, which is one of the key science that we are going to do with our observatory. Currently under construction in Chile, the observatory will have an 8.4 meter telescope and a 3.2 gigapixel camera. When we start science operation in late 2022, we plan to scan the whole sky once every 3 nights, and we'll do so continuously for 10 years. In the end of the survey, we'll have around 800 images for every location in the sky. In terms of data volume, we will collect around 20 terabytes of data every night. Over 10 years, that's going to be around 60 petabytes. And we'll take these 60 petabytes of raw image data into 500 petabytes of science-ready data products, including images and the catalog, including 37 billion of stars and galaxies. Doing such data processing from raw data into such big amount of data product is not a trivial task. And in this presentation, we'll show you an example how we might use GCP to make that data processing possible. Next, we'll have Flora to talk about our partnership between Rubin Observatory and Google Cloud.
Thank you, Hsin-Fang. My name is Flora Huang. I'm the customer engineer supports Rubin Observatory. Google's partnership with Rubin goes back more than 20 years, way before Google Cloud was born. Back then, we helped Rubin with the data strategy and the construction of telescope mirrors. This high-level long-term engagement resulted in the first proof of concept in 2018 with Rubin's data management team on Google Cloud, and the second proof of concept in 2020. And here we are today. The second POC was specifically focused on running large science pipeline on Google Cloud, and for which we have a lot to share. A number of key highlights if you want to zoom in this POC. First, Rubin have massive amount of data to store and process. Tens of terabytes data is very common for small astronomy data processing pipeline. Large pipeline reads and process hundreds of terabytes data, which sits in the object storage. This massive volume basically means low cost, large scale compute is extremely important if you want to make it work from the financial perspective. From the operation perspective, auto provisioning is key given the amount of pipelines Rubin wants to run every single day. Auto scaling is a key for the scientists so that they can focus on the data processing logic rather than the HTCondor cluster administration. Real-time monitoring is a great plus so that field jobs can be captured and analyzed for future improvement. With that, I'll pass it to Ross, our solution architect, to show you how we architect this workload on Google Cloud.
Thank you very much, Flora. What we wanted to do to work with the HTCondor cluster, which is the HTCondor is a scheduler. So what we wanted to do with Rubin was to make this easy, repeatable, and cost-effective. So when it comes to easy and repeatable, the key thing is to work with Terraform, which is a HashiCorp product. Additionally, we use Terraform to build the cluster, and we use another HashiCorp product to build the images that the machines run on. If you're familiar with schedulers, the schedulers will have a master node, as we have here, a submit node where you can submit your jobs. And then most importantly, we have our compute nodes. Now, the compute nodes, in order to run Rubin's load, is going to be hundreds of nodes are required. Now, if anybody knows about VMs, of course, to keep hundreds of VMs around is going to be very expensive. So when it comes to being cost effective, what we did was put our compute nodes in a managed instance group, or MIG as we call it at Google, which allowed us to do auto scaling on the number of machines. As soon as you submit a bunch of jobs to the cluster, we scale up the number of nodes that are available to do it. And speaking of scaling, we also put all of the data on Google Cloud Storage, which can scale massively to multiple petabytes of data and make it very effective and cost-effective storage. And another kind of storage we have is Cloud SQL, which allows us to do some of the management functions that are required for the Rubin scheduler. Additionally, we put in cloud logging, and makes it very easy for Hsin-Fang, when she has a problem, to find the issues that are going on inside the cluster. So if you think that's exciting, what we have now is coming forward to us is a live demo. So let's all put our hands together and hope the live demo goes well. Hsin-Fang, take it away.
To start the HTCondor cluster using Terraform, I first have to prepare my variable file, like the one I'm showing here. Then I could do Terraform apply and pointing it to this variable file and to get it started. I'll need to confirm, yes, that I want to build this cluster. And then you will go ahead and start all the VMs needed on GCP for this HTCondor cluster. In our setup, we have one VM for the HTCondor submit node, one VM as the HTCondor master node, and a pool of workers as the HTCondor workers. All these VMs are based on a pre-built image with the Rubin Science pipeline software installed in it. The worker VMs could be printable VMs or regular VMs, and here in the demo, I'm using printable VMs. I could also set the range of the number of the VMs I would like in this worker pool. For example, here in the demo, I just set the maximum to 10. I want the maximum of 10 workers in this pool. Now I come to the GCP console. The cluster is ready for use. I'm going to log into the submit node of the HTCondor cluster. So here I'm doing submitting from the VM. In theory, I could also say have my submit node on my laptop instead of having the VM dedicated as a submit node. Now I'm inside this submit node VM. I could do Condor status. Then it will show me the results and information of this Condor pool. For example, I have 2 Condor workers available for me to use. Before I submit jobs to the HTCondor cluster, I'm going to quickly showcase how I might use Rubin Science pipeline software on here. The Rubin Science pipeline software have a middleware there called Data Butler, which includes a data store and a registry. So I'm just going to set the configuration for that. It's basically an abstract layer for the data access. And I could use our command line tool, which is called pipe task. And this pointed to this configuration file to run some pipeline. I will need to tell the pipe task command what I would like it to run, what kind of task, what data you should use for this specific job. In this case, then the software will retrieve data directly from the data store, which is a GCS bucket. Then it would do some image processing and analysis. And then when it has output data, it will output directly back to the GCS bucket. It also has a registry, which is backed by a Cloud SQL Postgres instance. That's the place where we keep some provenance and other information of our data. Now this pipeline has been started. It will start to have some logs printing out. Then you will go ahead and do all the calculations. Usually, we wouldn't want to run pipeline directly on the submit node. We would like to scale it up and use the cluster for the calculations. So here it's just as a demo to see how it goes. So usually, we will want to run a lot of pipelines, and all these pipelines, a lot of jobs, and all these jobs will have interdependencies. That's why we usually put the jobs together, written as a workflow. Here's an example of how this workflow of job may look like. We could express the workflow as a graph. For example, all these blue job has to finish before we could run the red job, and the red job has to finish before we could run the yellow jobs. And the red job here is like a bottleneck. And while we run the red job, we cannot use too many VMs anyway. But when we run the blue jobs, we would like to scale as wide as possible. That's where the auto scaling is going to come very handy. So I had previously built a workflow of jobs that I'm just downloading now. This is the pipeline definition of this workflow. Then I'm going to submit this workflow. I'm using Pegasus to do this workflow submission. Pegasus is a thin layer, a workflow manager on top of HTCondor. You could let me submit the workflow, and it also provides some tools to monitor the workflow. For example, the Pegasus status command line tool could let me check that how the workflow is going, whether anything is done, and how many is being run right now. So anytime while the workflow is being run, I could always use Pegasus status to check again how things are going. For example, right now, I see some jobs are being run. There are some jobs idling. They are waiting for workers. As there are some jobs that's idle, waiting for worker, the managed instance group will scale up to add more workers to it. For example, now we are seeing more workers in this Condor pool. Fast forward about an hour later, I'm using Pegasus status to check how the workflow is doing. And I find that the workflow has finished successfully. I could come to GCP console and check on the managed instance group. In monitoring, I could see the auto scale size in the last hour, and we could see that in the beginning, the cluster was started small, and the cluster was scaled up as there were more demand for the workers. When some workers were idle, the cluster was scaled down. This demonstrates how auto-scaling works. Now we are all done. We could use Terraform to kill this cluster. Similarly, I will need to confirm, yes, that I do want to destroy this cluster. Then you will go ahead and clean up all the VMs, everything associated with this HTCondor cluster.
Hope you enjoyed the demo. There are a few key takeaways from the demo. First, we only pay for the infrastructure that we actually use, which saves cost overall. Second, on GCP, we could use infrastructure as code tools such as Terraform to easily deploy the cluster and do so in the repeatable way. Third, in terms of scaling, GCS scaling capability is really good. And the auto-scaling feature of the managed instance group is really helpful for complex workflow like our use case.
So thank you very much, Hsin-Fang, for that amazing demo. It went really well. So there you saw it, flexible infrastructure so that we can do more science and not have to worry about doing all that work on the machines in the background. HTCondor worked great. If you want to try out HTCondor, the really good news is that HTCondor is now available on Google Cloud Marketplace. Anybody can try it out. Spin up an HTCondor cluster, spin up as many compute nodes as you want to run, and get started with your science pipeline. If you have any questions, we're going to have a Dory link in this slide where you can click and you can add questions. We call it a Dory at Google. We'll have somebody answer the questions for you. So thank you all very much for attending. Thank you especially Hsin-Fang, and thank you Jess and Flora for helping with this whole presentation. And don't forget, if you want to learn more about Google Cloud infrastructure modernization, drop into our Ask the Expert via Google Meet link on this slide. A Googler can talk you through some of your toughest problems, and feel free to visit the website for any more information. So thanks very much.